Hello everybody, welcome back to the Moshix Mainframe channel. This is Moshix, and today I thought I'll pick up on something I said in my previous video, the one where I tried to install the updated Stanford Pascal compiler on MVS 3.8 and failed miserably, not for lack of trying, but because the installation package is a bit of a mess, if I may say that, with all due respect to the maintainer of the Stanford Pascal compiler, Bernd Appolzer. I know he's a great programmer, it's just the installation package is a little bit messy. But apart from that, what I said yesterday is that I don't do IBM mainframe stuff only. In fact, over the years I've tried a whole bunch of emulators. I've played with the 1401, IBM 1401 emulator, the 7094 emulator. Obviously, I do a whole bunch of stuff with the VAX emulator, and in fact, on this computer here that you are seeing right now on your screen, I have a huge installation of a VAX cluster with OpenVMS, and I think I'm going to do a video about that in the near future. The only problem with that is it's so massive that it uses almost all resources just to run it, this cluster, and very little processing power is left to run the video recording software. So I'll have to think how to go about that. Maybe I'll just record from a separate computer, and just log in remotely or something. I'll figure out something. But today we're going to be looking at something that for me is just a whole lot of fun, and that's a Cray supercomputer, which we're emulating, and obviously it runs hundreds of times faster than it used to run on the real Cray computer from back then. Let's just look a little bit of how the Cray computer looked like and what the performance specs, Cray 1 specs. So the Cray 1 supercomputer came out in 1975. It cost about $8 million plus another $1 million for the disks, and 80 of those were sold, and it was able to do 160 megaflops. So that's 160 million floating point operations per second. I think this machine here that I'm recording this on does in the neighborhood of about 4 billion floating point operations per second per core, and we have 4 of those, so that's about 16 gigaflops, if I'm not mistaken. It could be actually an order of magnitude more. It's so much I don't really try to even understand. But it was obviously designed by Cray Seymour, who was before the founder and major mind behind the CDC, or Control Data Corporation, which does not exist anymore obviously today. Seymour Cray has been gone for a while. He died in 1996, so 21 years ago. An amazing person, very disciplined, great logic designer. So this used to be a major machine back then. The Cray 61, the Cray 1 was a 64-bit computer. It has a very complex instruction architecture, and I've actually looked into that a little bit. And that's why it's always been very hard to emulate the Cray architecture. On top of that, very little has been done to conserve the Cray software, in the sense that there's not much left of the Cray software. And so there's this guy, oh, that's my own video, watching my own video. You caught me watching my own video. So there's this guy, Andrea Dantos, Cray 1. He went and first wrote a, that's not him. First wrote a Cray emulator, and then tried to obtain disk images of the operating system of CrayOS 1, but he didn't have an actual disk device which could read the disk and then transcode it into more modern computer files, such as we do obviously in all our emulated architectures. And so there's this guy, that's the web page I just opened. He was a student, I think, at MIT, and this person did something amazing, as you can see here. He created a little bit of electronic board, created this electronic board, and wrote a little bit of software to have magnetic heads spin on a disk device, like an improvised disk device. It was spinning the disks, and it had this magnetic heads reading the surface of the disks and just reading the magnetic impulses coming from the disk, and then transcoding them into files. And so then he had to go and then analyze those disk images to try to find the pattern of the bits on the disk, so that it could start to make sense and start to create bytes that belong to real file and recreate the file system. I mean, it's just amazing work. I'll put the links to these web pages when I upload the video, so you can read about this. He has a whole blog how he went and finally built this whole contraption so that he could read the disk images. And that's how we got the disk images, and that's how then later on Andrea Tantos, the guy who created these images, was able to recreate CrayOS 1 emulator. Tantos was able. There's also some YouTube videos. I'll make those available as well. Yeah, this is the one. So this person here is the one who put it all together. Now it also runs on Linux, but I see that there's some problems in compiling it on Linux, and so I just downloaded the version here from the web page. I found that from the last time I used mine, which was back, I think, in July. There's now a new version released, actually just a few days ago, and an updated version. So I'll just go and run this, and we'll see how this all works. Okay, so I have both versions. I have the version 2.1 from the download, and I have the older version. Okay, so let's run the older version, and let's do some fun stuff. So once you start, you have this one is kind of giving us the work that the emulator is doing. We see here IOP stands for IO processor. This is the CPU, it's still turned off, and these are consoles that are attached to the IO processor. So the Cray had the main CPU, and then it had like a computer in front of it that was dealing with the IO, because it would have been much too expensive to run normal processing on this very expensive CPU. And so the IO processor 1 or 2 attached in front of it was dealing with all the disks and tapes and reading jobs in and preparing jobs for execution. So so we have these 3 consoles. Those would have been serial terminals, obviously, back in those days. And so let's start the system. So in these consoles, we only have caps, uppercase only, as was normal in those days. So you have some help here. So let's start with 1.17 dead start, which is kind of like a cold IPL on the mainframe. What would it have been? Start. What is it again? It's cold. Okay. Maybe I have to do it from here. Start. Close 1.7 dead start. maybe it's this one then. Start. Yeah. So this starts to execute. You can see here the CPU is now turned on, and it started the CPU, and now we can log on to the Cray. From here, I guess. I was sometimes confused which one. Oh, I need to first start station. Sorry about this. Yeah, I need to do this here. Station. Yeah, we were missing the right terminal. So this will be now a console attached to the Cray itself. And once we're here, we can log on, and we're now in the CrayOS operating system. Obviously, this is not year 2000 compliant. Doesn't really matter. But we can now we can start a second console attached to the same session. Okay, so here it is, and here we can execute commands such as monitor CPU, and here we have CPU monitor, and we have some messages here. So L means this is status, the status line. We see here from L means logged on, and M means there's some message waiting for us. So let's go read it. Okay, so it's enter configuration changes or go to continue. We don't want to change anything, so we reply. This is for all the people who do mainframe and MBS on this channel. This is obviously all familiar. Reply, message number 0, and then go. Okay. And you can see here where the CPU gets busy when we do stuff. So now it wants us to continue, reply, 10, continue. And you can see this is all working just fine. Monitor disk. And we can also there's a disk command, and shows us all the disks. And you can see here which disks are working. Let's start maybe another console. Console 2. What we can do here, monitor IOP. And let's start console 3. Oh, there's no more consoles defined. So we can do here monitor CPU, and now let's see about executing some jobs. So to do that, we actually first have to tell the spooling system, kind of the JES2 of CrayOS, about which classes are allowed to execute. So we do class all on, I think. Yeah, and then limit 5, how many jobs can execute at the same time. So that is done. So we go here and say status so we can see the job queues. Okay, so this seemed to have gone well. Now what we need to do is actually enable interactive mode on the mainframe, and to do this it's IAI. Let me go check the command. The command is IAIOP log, IAIOP log. is this not working? Probably have to do it from a different. Yeah. Sometimes it's not clear to me from which console to issue those commands. But so this went well now, and now we're in interactive mode. We still have to log in. Okay, so we have to do now account. What is it? Actually, first we have to tell it we want an interactive shell, so we do that with IACon. Okay, and now that we're in interactive mode, we actually have to log on again. We have to establish a connection again. And what you see now is that the scheduling system sees now our interactive session here. It showed up, and so the login only establishes a connection. After we establish a connection, we actually have to then supply our credentials, which is account access code equals Cray, and there's a dot that we have to put at the end of the command for some reason. You can see how arcane this all is, and we're now logged in. I don't know if we have help. Yeah, we don't really have. I don't remember all the commands here. What I know is that to execute any interactive command, there's not that much software installed in this image here. First, the files need to be brought in from the I/O processor here to the CPU itself. There's a copy command. I think it's called fetch. Network, yeah, network must be specified. So we have to tell it what command to copy over, and then we can run a command. Let me look at the manual for a second. So I looked it up. It's a very complex command. Put it in my copy and paste buffer. So the command is fetch. The dataset name is Teddy. That's the editor. And then we have to tell it where from and where to copy it to. And here we do Teddy, and so it's going to do this. And I don't see anything working right now. Or maybe it is doing it. Yeah, the processor is executing something. Let's monitor. Let's just look at disk, because that's where we should see activity. It's not sending disk requests. That's weird. Yeah, looks like we kind of got stuck here. Obviously, this is the older version of the emulator. There may be a bug with the emulation there, something. And though IOP1 is where the disks are attached, IOP3 is where the tapes are attached. I don't know why this is so furiously working. It looks like it is doing something, but I'm not sure. Monitor disk. No, there's nothing going on at all on the few disks. Yeah, so this got a little confused. So I think I'll stop here. I don't really know much about the Cray operating system. I'm still learning, but this gives you a good understanding of how arcane this all was. We're talking about an operating system from mid-70s, which was interactive already. And just at about the same time, that's when IBM released TSO for MVT. So this is the very beginning of interactive console work. And I think it's very interesting, totally different, obviously, from the IBM mainframe operating systems. But here and there you see some similarities, like there's this scheduling system here, which we're looking at. You have classes, job classes. You see here, job class. You have I/O processes, which are called channels in the IBM mainframe world. So similar stuff. So this is it. I just wanted to show a little bit something different today, and I did. I'll make the links available below this video where to download all these images. You can. I'll make my image here available. Go and play with it a little bit. I think there's a Fortran compiler installed, and remember, this is obviously vector processing, so this should be quite interesting for people who do Fortran programming. That's it. I'm going to close here. Hope you had some fun watching. Thank you very much for visiting my channel and for all the new subscribers. And please do subscribe if you want to get notifications of future videos, and don't forget to press on the thumbs up button if you like this particular video. Thank you very much, and goodbye.